Hi everyone. Today we're going to learn about one-to-one functions. But before talking about one-to-one functions, I want to talk about this problem because this helps us learn more about the one-to-one function. So we have a graph here. We want to know what domain restriction makes the inverse of f of x a function. So let's see what's happening here. This is my graph and I want to find the inverse of that. Basically, I need to find a reflection over this line, which is y equal to x. In order to find a reflection, you need to find some points like 0 and 4 here, -3 and 1 here, and -6 and 4. Then, to find a reflection over y equal to x, you just need to switch x and y. So it will be 4 and 0, 1 and -3, and 4 and -6. Then you connect the lines. This will be the reflection of this graph over y equal to x. But here's a problem. The reflection of this graph is not a function. It is the inverse, but the inverse is not a function. Why? Because if I use the vertical line test, you see, if I take this vertical line and move it all over my function, I will see that I'm passing through more than one point, like this one and this one. This means the graph is not a function because for one x we have two y's. So how can we solve this problem? In order to solve this problem, we can just make some restriction on domain. The domain of my original graph is from -infinity to +infinity. But if I take one half of this, like this side of that graph, take this one off, then we will have only this side. The reflection of this line over y equal to x is this line. So we won't have this side anymore. So we get rid of this. Now, if I use the vertical line test, I will see that I'm passing through only one point. As I move it on my graph, it's always passing through only one point. Now the reflection of this graph, or actually the inverse of this graph, is a function. So how did I make this? By restriction over the domain. So I only took the x values which are greater than -3, because from this point we took off the graph. So it's only x's which are greater than or equal to 0. You could also do the other way, like you could take off the right side and only take the left side of the graph. Then the inverse would be this point and this line. Then we wouldn't have this side of the inverse. Now again, if you use the vertical line test, it's always passing through only one point. So here we took only the x values which are less than -3. I made a mistake here. This is not only x values greater than 0, it's actually x values greater than -3. So I'm going to correct myself. X greater than -3. So the first time we took only the half side of the function, which was x greater than -3, and we made it a function. We could also do it in this way, like take the left side of the function, and the left side is all the x values which are less than -3. So this is how we can solve this problem and find and make the inverse a function. Now let's see what is a one-to-one function. We're going to learn about one-to-one functions and determine if a function is one-to-one or not. A function is one-to-one if it has an inverse function. An inverse function means the inverse of this function is a function. Let me correct my spelling. This is function. Okay, now how do I know if a function is one-to-one? If for every y we have only one x, then that function is one-to-one. So let's look at these relations that we have. In this relation, we are mapping the set of x values to this set of y values. First of all, this relation is a function because for each x we have only one y. It means from each x we have only one line going out and mapping to only one y. So this is a function, but is it one-to-one or not? So we're going to look at the y values. Do I have only one x for each y? Yes. So for 2 I have only 1. 4 has only 2. 6 has only 3. So for each y I have only one x. So this is one-to-one, a one-to-one function. How about this relation? Again, we are mapping x, set of x to set of y. This relation is a function, so this is a function because for each x we have only one y. Like 2 has only one y, which is 4. This negative 2 also has only one y, and that's 4. So this means we have a function here, but is this function one-to-one? So we're going to look at the y values. For this y, which is 4, we have 2 x values. So this y goes to 2 x's. So that means this is not one-to-one. The third example here. We have a set of x values mapping to y values. Let's see if this is a function. It's not a function because for one x I have 2 y's. Like one arrow is going out from this y, this x. So for 4 I have 2 and negative 2. So this is not a function. If I don't have a function, I'm not even going to consider being a one-to-one or not. So a relation has to be a function, then it can be a one-to-one function or not. Okay, another way to figure out if a function is one-to-one or not is to use this rule. You need to use the horizontal test line. If it passes the horizontal test line, then it's a one-to-one function. Let's see how that works. We have f of x equal to x squared. I'm going to graph this function. We know that the graph of x squared looks like a parabola this way. Then I'm going to use the horizontal line test. So I'm going to use a horizontal line and move it over my graph. If it's passing through more than one point, then it's not one-to-one. Because it's passing through more than one point. Now let's graph the other function, y equal to x to the power of 3. The graph of x cubed looks like this. It's something like this. Now I'm going to use the horizontal line test. So I use a horizontal line, and as I move it on my graph, and I see that always it's passing through only one point. Always passing through only one point. So this one is 1-to-1. So that's how we can say if a function is one-to-one or not. So this was today's lesson. We're just going to talk a little bit about some properties of composite function and inverse function. So if a function is one-to-one, then it has inverse function. We learned that domain of f is range of f negative 1. And range of f, here's a typo, range of f is domain of f negative 1. To verify that f negative 1 is inverse of f, show that f of g of x is equal to g of f of x, and they both equal to x. So that's what we need to prove in order to verify f and f negative 1 are inverse of each other. You could also write it in this way because we have f and f negative 1. I'm going to change it by f and f negative 1 instead of f and g. So f of f negative 1 of x is equal to f negative 1 of f of x, and they both equal to x. So if you prove this, that means f and f negative 1 are inverse of each other. The graphs of f and f negative 1 are symmetric with respect to y equal to x. So this was today's lesson. Hope it was helpful for you. Have a great day.